Let's begin. Let's apply this definition to our second problem. Here it is. Show that the limit as x approaches 4, 2x minus 7. Okay? Now, here we've got a linear function. We know it is continuous, right? And by direct substitution, we're going to substitute x as x approaches 4 into this function in order to get the output at that point. So for instance, 2 times 4 is 8, 8 minus 7 is 1. Okay, now let's begin our proof. Let's write down the proof. The object of this exercise, we're given an epsilon and we need to find a delta that will work for any given epsilon. So the proof, we're going to write down, let epsilon be greater than 0 be given. Okay, and we're going to choose a delta. That's what we have to find. And let x satisfy this condition. X minus 4 is less than delta. By the way, this is called the hypothesis. So let x satisfy this condition, and then we're going to actually do the proof, right? So we write down f of x minus L minus 1. This is the f of x function, and that's the limit L. Okay? Right, let me just rub that out now. Okay, so you can see clearly what I'm doing. Right, let's begin by writing brackets 2x minus 7 minus 1, right? And we want that to be less than epsilon. So we're starting from here and we're working backwards to achieve this goal, right? So here we are. Let's begin the proof. So we're going to have 2x minus 8. Then we're going to have, we can factor out the 2. So we got 2 into x minus 4. Continuing simplifying, we can now write that as 2 times the absolute value of x minus 4. Okay? And what do we notice? We know something about x minus 4. There it is. This is called the premise, the hypothesis. We know that x minus 4 is less than delta. So we can write this, as rather less than 2 times delta. There's x minus 4, and that's related to that. So we can write that in that format. We want this to be less than or equal to epsilon. So from that, we can, let me write it this way. We now have twice delta is equal to epsilon. And if we divide both sides by 2, we've got delta is equal to epsilon over 2. Now we have found a delta that will work. We have found a delta that will work for any given value of epsilon. So we have ended the proof here. And we can go back up here and we can write delta is equal to epsilon over 2. This is a delta that will work for any given value of epsilon. This is what the definition is saying. The limit as x approaches c, f of x approaches some finite limit, implies for all values of epsilon greater than 0 there exists a delta, and we have found that delta for any given value of epsilon that will work satisfactorily. I do hope that this video helps students, and please don't forget to subscribe. Thank you very much for watching.